Hello again. Let's continue on. The next thing for us to do, I think, is we now have the ability to read in an image and manipulate the pixels and write out the image, but we don't have an easy way to manipulate all the pixels. And a very common operation is we want to visit every pixel, do some transformation, and then put a different pixel in that place. So what I'd like to do is write a function for doing exactly that kind of thing. So let's create in our image class, let's create a public function. Okay, I'm going to call it transform pixels. So we want this to transform all the pixels. We're actually going to pass in the function that's going to do the transformation, and that's a pretty cool thing, I think. So I'll call that the transform function. And what does the transform function do? Well, it takes an RGBA pixel and it'll return an RGBA pixel. Simple as that. Okay, and as a result of all this, we're going to return a new image. Now I want to make a point of this. We're going to return a new image rather than mutating the current image. It's usually a better practice to try to return immutable objects, and that's what we're trying to do here. So, continuing on, what do we need to do? Well, first of all, we need to create a new image to copy into. So let's create, I'm going to call it a copy constructor. So it's very similar to the original initializer, except basically we want to be able to, let's see, create an image of a certain width and height. So I'm just going to say width, that's an integer. So this is an uninitialized image, and height, that's also an integer, right? So now the width and height, I'm going to say self.height and self.width are equal to what we're passed in. Right. Oops, I see my typo, don't worry. There we go. Okay, now the rest of it, let's see. Bytes per row, well, we still need to initialize bytes per row, and that will vary. We still need to create this, allocate this, but we don't need to do this step, and we don't need to do that step. So we're basically no longer copying from the image, we're just, creating the buffer. And that feels right. Okay, so now we've got an initializer that will initialize an image for us. So continuing on, and I'll call it new image equals image where the width is what? Is it's the current width. So we'll say self.width, and the height is self.height. I hope that makes sense to you. It makes total sense to me. Okay, so we've just created an image that's just a buffer. Right? It's just the buffer, but it's big enough to hold an image of this width and height. Okay, now we want to iterate through each of the pixels, and we'll start by basically we work from the top down because that's mathematically the easiest way. So we're going to go for y equals 0. For y in 0 through the height. Right, so it's basically going to start at 0 and go to height minus 1. And then we do the same thing for x. For x in 0, ... and that's obviously the width. Sweet. Okay, so we're now iterating over the height and the width. We want to get the current pixel. Now, rather than before, we don't want to write that logic again. We want to get pixel function now. So let's write it. Yeah, it's a good spot as any. So we'll go public get pixel. We'll say width, not width, x. X is int, y is int. So we want to get the pixel at the XY location. And this is pretty easy to do. We go to our pixels buffer. Right? And we know the layout and the organization of this. It's simply x plus y times width. Right? Oh, and this is a function that returns, what does it return? It returns an RGBA pixel. Sweet. Now I'm gonna, oh, what is it complaining about? What is it complaining about? Oh, right, I forgot to put the word function in there. It's a function. There we go. Okay, now we're going to need to, we're also going to need a setter. So I'm just going to do that right now. I'm going to, you know, it's basically the set pixel. We're going to pass in a value, which is an RGBA pixel. And this just mutates the value. Okay, those make sense to me. This reads the current pixel out of the buffer. This one sets it. Okay, now we can do our transformation. So we know our x, we know our y, so we can get basically, I'll call it P1. So this is the source pixel. I'll do a get pixel, add x and y. Oops. Undo that. X, y. Okay, so P1 is the source pixel. What do we want to do with the source pixel? We want to transform it. So I'm going to go let P2 is equal to, and we call our transform function. Right? And we pass in our source pixel, P1. And then finally, and I'll figure out why that's not looking right in a second. When this is done, we want to update our new image. New image dot set pixel to the P2 value at location X and Y. Sweet. Okay, now let's see what I did wrong. I bet you I forgot for Y. I think I need a let in there, right? For, no, that's not right. What is it? Braced block of statement is an unused closure. What is up? Let's look at this again. For y is, oh geez, you get this. I think I need a space. And I think I need a space here. There you go. I'm actually glad that happened. Hopefully it doesn't happen to you. That one gets me quite often. Okay, so we've done our transformation, and now new image is what we can return. Yay! Oh, and let's get our closing brace in the right spot. Right, okay. That looks pretty good. Get rid of these breakpoints. Now let's go back to our main function at the moment. That's this guy. Right. So we have an image. So this is the original image. And we want to do a transformation. So let's just add a transformation function. Let's quickly create something called, let's see, half intensity. Half intense. Right. So this has to be a function that takes a pixel, a p, and we'll call that an RGBA pixel. Great. And it's going to return an RGBA pixel. Okay. So what's this going to do? Let's go let p, I'll say p2 equals p. Okay. Now this is interesting. Because this is a structure, it uses value semantics. So saying p2 is equal to p means it is taking a full copy, a full independent copy. So now I can take my p2 and I can visit each of the parts of it. I can say red is equal to p2 dot red divided by 2. Right? And okay. I'm just going to say return p2 because that's eventually what we're going to do. And of course, this has to be a var. I'm mutating it. Okay, p2 dot blue is equal to p2 dot blue. It's not going to be minus divided by 2. I'll fix that in a second. p2 dot green is equal to p2 dot green. And that looks pretty good. Okay, so we now have a function that takes an RGBA pixel and returns an RGBA pixel. So we can now call our transform. So let's do that. Image.transform pixels. Right? And let's call half intensity. Ooh. We want to pass in this function here. Right? And this is going to return an image. So just to make it clear, I'll go let I2 is equal to that. And then we're going to take I2 and do 2image on it. Okay, let's just see what happens. So here's the original picture. So now we're taking that original picture, running our transform. We're passing in a function that's going to, for each pixel, it basically cuts its intensity in half. Okay, and then we take that image and then we transform it back to a regular UI image. Let's see what happens when we say compile and run. So if all's well, we should see an image that's about half the intensity. And that looks pretty good to me. That looks like half the intensity. If we want to, change red to blue, blue to green, whatever, yeah, the image would update appropriately. So that's a good point to stop at. I'll just stop our thing and I'll save our latest checkpoint. And I have been doing this religiously. Well, I have been doing this. So I'm going to go commit. And what have we done in this part? We have added transformation function for simple image manipulation. Very nice. Okay. Thank you very much.